Hi, everybody. Mr. Rubo here, and we are continuing with 2.8. We're talking inverse functions. All right, so if f and g are inverses of each other, then we would write g of x is equal to f inverse, or f to the negative 1 of x. With inverse functions, all of the x and y values are switched. So the graphical behaviors in terms of x and y will also be switched. In other words, the domain of f is going to equal the range of g. And same with the range of f is going to equal the domain of g. And that should make sense, right? If you're switching your x and y's, the x's, which we call the domain of f, would now become the range of the inverse. And then the range would become the domain, okay? Gives a little note here that if you're strictly increasing or strictly decreasing, that it won't pass. A continuous function will only have an inverse function if it is strictly increasing or strictly decreasing. So if you're not always going up or always going down, the inverse won't be a function. Still has an inverse, it's just not a function. Okay. All right. So here we have x and f of x in this table, and we're told it's a continuous function with selected values in the table. And then it says let g be the inverse of f such that g of x equals the inverse. So what we want to do here, before I even get going, I'm actually going to write a new table. And I'll actually just write it right above here. I'm going to have it of the inverse. So I'm going to say f inverse of x, which is equal to g of x. I'll have the x's. And I'm literally just going to take my table below and switch the x and y's. So 6, -3, 3, -2, 1, 0, -1, 1, -3, 4, and then -7, 6. And there I've created this table. Now I can start doing some composite functions here. So first one, I actually didn't even need it, but it's still going to be helpful for the rest of them. So f of 0, well, f of 0 is 1. So I'm going to say, okay, well, f of 1 is now what I need to find, which means my answer is -1. So doing a little composite functions here right off the bat. All right, then b is g of -3. Well, g of -3, I've already written the table, so I just get 4, right? Just pulling it from the table. G of 6, pull it from the table, I get -3. Okay, that's why writing that table beforehand was really helpful. All right, now we're going to go composite functions here. G of -1, or g of -1, sorry. So let's start with g of -1. Well, g of -1 is 1. And then I'm going to do g of 1, which is 0. And there's that answer. Okay. All right, now this one switches the notation, but remember, f is also, f inverse is also g. So we do it from left to right. So f of -2 is 3. So then I want to do either g of 3, or you could think of it as f inverse of 3, which then, look at that, it brings me back to -2. And that's a very key concept of inverses, is it kind of undoes the function. Okay. And then this guy is actually the same exact question as b, just a different representation. Because again, g and f inverse are the same thing in this equation. All right. That is it for today's notes. So thanks for watching. Have a good day.